Hey, do word problems make you or your team just shut the book and walk away? I'm done. You're not alone. Word problems are the most frustrating things to people that are doing algebra and really any kind of math. We see it early on, but they really kick up in algebra and beyond. And they just really cause great grief. I remember just despising them, thinking, why are we working word problems? Shouldn't we just have equations here? And that makes life so much easier. And the reason we struggle with word problems isn't because we're bad at math. It's actually because it's like a riddle written in a foreign language, and we just got to get our head around it. So, what I want to walk through here today is a quick way to unpack these word problems. It's not everything, but it give you some things to get moving. And oftentimes, that's all you need is just a little bit to get moving. One, and we're looking at developing a word problem toolkit. That's hard to say. A word problem toolkit. If you're interested in a toolkit that'll help you solve word problems that you see and help you get past the getting stuck on them, send us a message toolkit and or either on Facebook or email or Instagram, wherever you see us, and even here on the YouTube, we'll and we'll get you linked in to that when that comes out. All right, so why word problems feel impossible? Let's talk about that for just a minute. Uh, is what we're dealing with in a word problem is not one problem. What we are dealing with is two problems, all in one, and that makes it sound worse, right? Gee, now I got to solve two problems. But the first one is a reading problem. All right, so it's not a math problem really. It's what is the word saying? And the second one is the math problem. Once we figure out what the words saying are saying to us, we have a math problem. And most students, the math problem, they can do that because they've learned the math. But what happens is when you try to jump from the words straight to the math problem, then you're frustrated. And that's where most people get stuck. They don't even know what to do with it. So they'll look at that and say, I don't know what to do with this. So, all right. So let's talk about a three-step method of how to do this. And so first we want to do is I'm going to just show a screen here. Is we're going to just say what is being asked. So number one is what. What is being asked of us. The this so highlight the question and we would say, what are we solving for? We'll look at an example in a minute. The second thing we want to deal with is a translation. Uh, and we want to translate from English to math. And to do this, we look for keywords like total, difference, twice, per. So we're looking for these things that will tell us. And the more you do these, the easier they get because you can just kind of read into what they're saying. And by the way, how we talk about real life is in real words. We don't usually write down equations, but we're talking math all the time. This is one of the things when people talk about, do we ever use algebra? Yes, we talk about it constantly. We don't often translate into equations. The third thing here is after we translate to is just to set up and solve. This should be set up and solve. Okay. So those are the three steps that we're doing when we solve a word problem. Define the what, do the translation, and then set up and solve the equation. The third part is usually the easy part once you get there. Okay, so that's the process. All right, we're all done here. So let's walk through an example. So I'm going to just read this out because I didn't write it down. But we have two trains. Well, let me just do an example here. We have two trains leaving a station at the same time. Okay, so two trains. There's train one and train two, and they're leaving. And this one goes 50 miles per hour, and this one goes 60 miles per hour. So those are two trains leaving the station at the same time. How long until they're 30 miles apart? So I'm going to say, how long before 30 miles? Okay. All right. I'm not showing you the problem, but that's what it says. So now just to kind of back through, now this is a typical problem you would see in algebra. So to backtrack through what we're doing here is what are the steps? So let's just separate these out so we know what we're doing. Is what are we asking for here? So in step one is, well, what are we asking for? He's asking for how long until they are 30 miles apart. So I'm going to just say how long, and that's exactly the way it's worded in the problem that I'm not showing to you, but that's how I said, how long until they're 30 miles apart. So how long, which is time, minutes, seconds, hours, okay? That's what's being asked for. Find the time. Okay, well that makes sense. Now, if you're helping your student and they're sitting there looking at this equation, and if we look at our last video last week, how do you help your student that's stuck? This is exactly what you're looking at this problem, and it says two trains leave the station at the same time. One goes 50 miles, the other one goes 60 miles per hour. The other goes 50 miles per hour. How long until they're 30 miles apart? Step back and ask your student, what's being asked for? If you can just get them there, we're being asked for time. Okay. You're being asked for time. You've already got the first thing, right? That's the first part of the problem. The second for the problem solving is to translate. Okay? So in this translate, what we want to do is we want to say, when I look at time, and we just kind of look at the problem, what's going on here? Well, time, that's a distance. And if you studied algebra, that's supposed to be distance or a rate problem. That's what we call them in algebra, distant rate problem, where is the distance is equal to the rate, usually called r, times the time. Okay, that's the thing we're dealing with here. So that's the translation I'm dealing with. I've got a time. Notice I've got two rates. Those are rates. Miles per hour. And again, notice the words. Now it's written down MPH in this problem, but miles per hour. How long? That's the question. So okay, all right. So now we can see that's the translation that we're dealing with. So distance is rate times the time, and what the question was is how long before they are 30 miles apart. So that's the distance, right? Okay. So now what we can do is say, well, now let's try to pull this into an equation. Is if we think about 50 miles per hour, well, let's think about the bigger one, 60 miles per hour times the time. So that 60 miles per hour times the number of hours gives us how many miles it traveled. So we're going to solve for distance here, right? Because this is a distance equal rate times time. So then we're dealing with 60 times t, we'll call that the amount of time, minus the distance of 50 times t. That's the difference between the two. One is going 60, one is going 50. And we want the difference to be 30 miles, right? Okay. So that's what's going on here is now I may have taken a little leap, and so you might want to write more down here, but this is that last step. We're translating. I might have spent more time writing things down here, depending on your student, right? But this is the equation we want to get to from here. I'm kind of thinking through the process. I'm trying to get to when are they 30 miles apart, and notice there's an equal sign. Oftentimes when you say when, it means all the stuff on one side's got to equal to 30 miles, and this is 60 miles per hour times time. This is miles, and this is 50 miles per hour times time. This is miles. So the amount of miles one train went different from the amount of miles the second train went is 30 miles. So that's what I'm writing down here. You might write this down in a couple more steps. For instance, I might say, well, 30 miles is the difference between train 1 minus train 2 miles. I might have written down something like that just as I'm thinking through it. Well, train 1 miles is going to be 60 miles per hour times time, minus train 2 is 50 miles per hour times time. Now I'm just writing down the same thing I wrote down here, and it's all going to end up back like this equation. Now, if you don't understand this, that's not the point. If you're like, it's been forever, don't get this. The point is looking at the process. As mom and dad, even that we're not doing algebra, we can know here is a process. We can show our kids this video. We can say, okay, this is a 3-step process. Identify what's being asked. Mom, you can come in and say, what's being asked for? Time. Okay, got that. Translate words into math. You don't have to understand this. You get them to repeat it. You just get them until they can say, okay, it's this. You get them to start writing things down. And then let's get to solve the equation. Okay, how are these things related? When we say solve equations, equation is by definition a relationship. How one thing is equal to another. And so if you just start asking about this kind of in normal language, it helps your student think through it. But this is the process, right? So if I solve this problem, I can solve for t. This now is 60t minus 50t equal 30. This is a very simple equation that any of us might even remember. It's 3. What that means is going to be 3 hours. Okay? So there's an example of this with a classic train problem. All right, so let's look at this with a, let me scroll up here and look at another example, a money problem. And so let me just say this example 2 and say Sarah has $5 more than twice. This is the kind of problems I always hated. Then twice what Ben has. I'm writing this one down better if that helps. If not, because you can't read my writing. Together, they have $29. How much does each have? All right, so how much does each have is the problem. All right, so again, let's start with step 1. So I don't have it written down here, but step 1 is identify what is being asked. So what is being asked here is the amount each person has. So I'm going to say the amount Sarah has and the amount, I'm just going to spell it out differently, and the amount Ben has. Okay? I'm asking for 2 amounts, and these are going to be dollars, right? Just so I know, I'm looking for the dollars Sarah has and the dollars Ben has. What? It may be dollars and cents, but we'll just go with dollars. All right, so now now we know what we're looking for. How much money does each have? It says that, but again, we want to stop and think about this is what I'm solving for. This is a super trick for the ACT, SAT, is remember what you're solving for. Translate. So the second thing is here is translate. I didn't write that down the first time. So now what we got to do is take what's written and try to take the words and make it into something. You'll notice a couple of words here. 5 more, right? There's an equation there. Twice, there's a number. Together, that means addition. Twice means 2 times, and $5 more means plus. Okay, so I'm gonna just do this. 4 means plus. Twice means 2 times. That should be a plus symbol. And what else did I say? And together means add. All right. Now that sounds goofy, maybe it doesn't, but sometimes you kind of need to just slow down. Notice what we're doing is slow down. I'm spending more time writing than I would typically. If your student knows how to solve this, they may jump to something faster. But if they don't, start writing. Because you'll notice I'm just writing things down and I'm translating this not only in my head but in paper. And that helps us think through it as we put pen to paper. It's amazing what can happen if I start doing this and learning to do this. And this is a big trick for students because a lot of times they don't want to put pen to paper. They just want to look there and solve the problem because that's what they're used to doing. All right, so let's just pretend. Let's go with algebra. Let's set Ben dollars is equal to X. The amount of money Ben has, I'm just going to call it X because that's what we do in algebra. We call things X. It's just as easy. Now, why do we call it X? We could call it B for Ben, but sometimes when you start writing letters out, it gets a little confusing because it looks like numbers. So X and Y are usually good ones. So there's Ben. If Ben has X, then what does Sarah have? Well, how much money does Sarah have? Well, we know that Sarah has $5 more than Ben. No, then twice what Ben has. Okay, that means we take what Ben has and we double it. So this is going to be 2Ben or 2X. I'm not going to write that out, but I might have written out 2Ben, but it's 2X. And then $5 more than that, plus 5. Now notice there's an equation. So Sarah has 2 times what Ben has plus 5 more. And that's what those words up there said. Okay? There is part of the equation. There's the translation. So now here, let's get the total equation. So now the equation I'm looking for, this is bring everything together, is what do they have? How? What does each one of them have? Okay, so we're going to have a couple steps here. So together, it said they have 29. Is that right? So 29 is together. So when we say equation, something is equal. So 29 is equal to what Ben has plus what Ben has plus what Sarah has, which is 2x, we'll put it in parentheses, plus 5. There's my equation. 29 equals x plus 2x plus 5. Now I can solve that with general equation principles. Okay, so and now I can get, and I'm not going to bother with that here, but is x is equal to 8. Now, but this is important because if we solve something in a word problem, is we're almost there. This means Ben has $8. Now, how much does Sarah have? Remember, Sarah has 2 times the 8, which is 16, plus 5 more. So Sarah has $21. Okay, so notice all we're doing here is we're taking this stuff and we're going through this process. We're going from what's written in words, what's being asked. Number one, if you can just get your student to say what is being asked for. And sometimes that's a little tricky, right? You want to just pull out what's being asked for. And that's where even if you don't know the language, you can usually, I mean, if you're not a math expert, you can easily help even in that. And then translate it. Okay, now with that, you notice how I found these words. On the last one, I found the words more, twice, together. And on the first problem, we had, what was I being asked? A train problem. We had 2 trains leaving the station at the same time, means that they're in the same place. How long? That's time until they're 30 miles apart. So there's clues, right? And so we're looking. That's when we say translate. We're looking for the words What do those words mean, and what's the translation going on there? So step 3 is again, we want to look at what is the equation. As I put these words into an equation, how does that work together? And that's the part that usually they're comfortable with, and well, that's the part at least we're usually used to in the math. So now word problems stop being scary once you know how to break them down. And actually, word problems can become more fun once you know how to break them down. And this is key for ACT, SAT type exams as you move toward that. It's also really key to understanding algebra and mathematics in real life. We don't usually talk in real life in equations. We talk just like we just did about these problems in English. So if your teen needs more step-by-step guidance, if you would like a plan, again, let us know. Toolkit, send us an email and just say Toolkit. If you're interested in that when that comes out, send us a Facebook or whatever, wherever you find this. Just put the word toolkit, and or I would like to get the word problem toolkit, however you want to use it. We'll get your name on the list because we're going to just kind of try some things out. And we're only sending it to the people who expressed interest. All right, so very good. So thank you for your time. If you are having problems with these word problems, and if you're trying to learn them better, then you would probably be interested in our algebra course, online course, because we do work you through the word problems. And again, if you're interested in some specifics of how to work word problems, which is a big deal for your math, just let us know with the word toolkit. We'll see you next time.